Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So this question is asking us for the resistance, the current, and the voltages across the separate sections of the wire. So we have the length of the total wire, 10 meters, and then we have 5 meters of aluminum and then 5 meters of copper. The diameter of this wire is going to be 1.44 millimeters or 0.00144 meters. We have a voltage of 95 millivolts or 0.095 volts. The resistivity of copper is equaling 1.68 times 10 to the negative 8 ohms meters. And then the resistivity of aluminum is going to equal 2.65 times 10 to the negative 8 ohms meters. So for part A, they want the resistivity total is going to be equal to the resistivity. We should first find the resistance of the two separate sections of the wire. So the resistance in the copper section is going to be equal to the resistivity of copper times the length of the copper section divided by A, the cross-sectional area. So this will equal 4 times P sub Cu, or rather rho sub Cu times L pi d squared. How we got the factor of 4 is from the area, because area equals pi r squared. So this will equal pi and then d over 2 squared. So this will simply be equal to pi d squared over 4. And at this point, we can solve. So the resistance in the copper section will be 4 times 1.68 times 10 to the negative 8, and then times 5 divided by pi, 0.00144 squared. And this is equaling 0.05457 ohms. Now for the aluminum, we have 4 times 2.65 times 10 to the negative 8 times, again, 5 divided by pi times 0.00144 squared. And this is equaling 0.8607 ohms. And the total resistance simply equals the resistance of the copper section plus the resistance of the aluminum section, and this was going to equal 0.141 ohms. So this would be your final answer for part A. This will be the resistance of the entire length of the wire. Now for part B, part B is asking for the current. So the current is simply equal to the voltage divided by the total resistance. So this will be 0.095 divided by 0.141 ohms. And this will equal 0.7676 amperes. So this will be the current, and this will be your answer for part B. For part C, now, we need to find the voltage across these two sections. This is simply going to be equal to the current times the resistance in that certain section. So for aluminum, it'll be I R aluminum, and this will equal 0.676 times 0.05457, and this will equal 0.037 volts. This will equal 0.676 times 0.08607, and this will equal 0.058 volts. Now, mind you that this plus this is going to equal 0.095 volts, which is the same amount as what we got in the beginning right here. so we know that we are correct. So these will be our answers for part C. That is the end of the solution. Thank you for watching.